In this video, we are going to demonstrate the different approaches that you can use to select which variables should you include in your multiple linear regression model in STATA. At this stage, I guess you've already tested for the different assumptions of linear regression, such as linearity, independence, normality, equivariance, and you've also tested for outliers and collinearity. We have separate videos. You can be sure to check them out for each of those assumptions. We shall also be covering the rest of the steps in our subsequent episodes, step 3 up to 5. So consider liking and subscribing to the channel so that you don't miss out any of our episodes. Quite often during our data collection, we collect data on very many variables, but we face a big challenge when it comes to analysis. Maybe you have over 50 variables and you're wondering which one should I leave out, which one should I include in my multiple linear regression model. So let us look at the different ways you can select which variables to include into your multiple linear regression analysis. First of all, if you have got adequate sample size, then you can include all the variables into your linear regression model. By adequate, we mean at least 40 cases per variable. Other books recommend as low as 25 cases per variable. However, this also depends on the type of study you're conducting. Sometimes some studies really you cannot have the leverage of having all that required sample size, so you can always consult your subject matter experts in that field. This is what we mean. If this is my data set that is having my outcomes, systolic blood pressure, and I have these 4 independent variables that I want to use to predict systolic blood pressure using linear regression. So altogether, I do have 5 variables, and that means I need 5 times 40 cases. That's about 200 participants. So I need a minimum sample size of 200 participants if I'm to include all these variables into my model. So if you have 20 variables that you want to analyze, that is 20 times 40. You need around 800 participants. So that's the first step, checking whether you have adequate sample size. Our focus today is going to be on scenarios where your sample size is inadequate, which is very common in the real world settings. There are 2 approaches that you can use to select which variables to include if you have small sample sizes, if you can't meet the requirement we just discussed above. Either you can choose the statistical approach. Statistical approach basically means doing a bivariable, others call it bivariate analysis, where you have your independent variable versus the outcome, only 2 variables into the model. And we select those variables that have a p-value less than 0.2. We shall be looking at this shortly. Then the second approach is using prior criteria or literature review, knowledge from your literature search, regardless of the statistical significance. If literature suggests that this variable affects my outcome, then I have to include it, regardless of whether it is meeting the statistical criteria or not. So let's start with looking at the statistical approach. So by looking at my variables here, I have a total of 5 variables, but when I look at my sample size, I have about 100. Yet I would need 5 times 40, at least 200 study participants for me to be able to analyze all the variables in my data set. So what I would do is now to go in for the statistical approach of running by variable or bivariate analysis and select those variables with p-values, smaller p-values, showing that they may be important in my prediction. So basically what we are doing is running a linear regression model with only the outcome and each independent variable one at a time. To do this, simply go to Statistics, go to Linear Models and Related, then select Linear Regression. In this dialog box, we specify our dependent variable, which is systolic blood pressure, and then we put in one variable at a time, which is shall start with age, and then I'll just submit this. So here is the output for the bivariable linear regression or bivariable analysis, where we have our outcome and the independent variable one at a time. We are interested in looking at the overall p-value for the model. If the p-value is less than 0.2, then we consider this variable for multivariate linear regression or multiple linear regression. We shall do the same thing for the other variable, which is BMI. I submit this. For BMI, we can see that yes, the overall p-value is also less than 0.2, so we are going to use BMI as well. Then when we look at another variable, which is gender, I submit. You can see that the overall p-value is also less than 0.2. We do the same thing for, and first remove this, then we run the same for smoking status. Click OK. Then we can see that the overall p-value for this model having smoking is 0.4293. So it is showing less significance in predicting our outcome. Using this approach, we are going to leave out this variable. We can't consider it for our multiple linear regression analysis. So whether you have 100 variables, you would still do the same for all the variables. It is like a screening method to see those with lower p-values. They have great influence into your model. So that would mean my linear regression model would have the first 3 independent variables. I'm going to leave out smoking. I can just pick the command from here because it is the same. We have our outcome there. So I'm going to replace the independent variables, age, we have BMI, we have gender. Smoking is left out because the p-value was above our cutoff. So this is how my multiple linear regression model would look like with only age, BMI, and gender. So that's the statistical approach you would use to choose which variables. But we also have the a priori criteria, where you select variables guided by literature regardless of the statistical significance. This approach is also referred to as the logical model building. You don't allow the statistical software to dictate for you what variables you should have in your research. So if in my literature review, I know that smoking status really affects systolic blood pressure, that is well known everywhere. So if I leave it out, really my analysis or my conclusions will be questionable. I would include smoking status regardless of its statistical significance. So at the end of the day, I would have these variables into my model, even when this variable is really showing a very high p-value or high levels of non-significance. So far, you can notice that when we browsed our data, we saw that these two variables, gender and smoking status, are categorical variables. But when I'm putting them into the model, I was just treating them like any other numeric variables. I wasn't differentiating between categorical and numeric variables. This is because if you have a binary categorical outcome, the coefficients and estimates you get will be the same whether you treated it as numeric or whether you specified to STATA that this is a categorical variable. So if we are to specify that gender and smoking are categorical during our model building under statistics, linear models, and linear regression, let me reset this, where we have our outcome, which is systolic blood pressure, and then we have our outcome variables. we would use these three dots here to show that this is a factor variable, and we specify that factor variable, which is gender, and then we click on add to list. Then we also do the same for the other variable smoking, and then we click on add to variable list. When I click OK, you'll see that those two variables have I dot before the variable name, indicating that this is a categorical variable. So when I click OK, now instead of just these variables being treated as numeric gender here and smoking, we now have one category being made a reference group. If you look at gender, these estimates are for males compared to females, and these ones are for smokers compared to non-smokers. If you wanted to change the reference category, for example, you want to show estimates for females compared to males, you need to first know how your variables are coded. So if I click on data and then describe data, then I come to describe data contents or code book, I can specify the two variables that I want to know how they are coded. Then I click OK. Females are coded 1 and males are coded 2. That's why the lowest coded category is used as the reference. Same thing here, the no's are being used as the reference. But if we want to reverse that, we can just come here. I want now to make category 2 the reference. I'll just say IB and add the 2 to make that the base. I click enter. Then you will see that the females have been made the main, whereas the males are the reference category. However, before we even made those variables to be categorical, you could see that coefficients for gender, for example, were 2.74 and standard error 1.87, which is the same output we get when we specify that gender is categorical and this is male. The same value 2.74 and 1.87, even the p-value 0.148. Even this side we had 0.148. So when you have a binary categorical variable, it only has two values, 1 and a 2, or a 0 and a 1. So the calculations will remain the same as if it was a numerical variable. Now that you know which procedure you can use to choose which variables to include in your multiple linear regression model, and you now know how to change reference groups for categorical variables, next we are going to look at how to assess for interaction effects in multiple linear regression model. These are all a series of steps that you have to conduct so that at the end of the day, your results are not misleading. If you found this video useful, consider liking and subscribing to the channel so that you don't miss out any of our episodes. See you in the next video.